Okay, so I'm on 11.4. This is kind of the crux of the subject. This is the stuff you're most likely to see. So a few things about a differential equation. So when they give us a differential equation, this is telling me who the variables are. So the variables here are y and t. They would have an input of t and an output of y. If you ever get confused, just think dy dx, which means k is a constant. So this here is number one because this is like the most likely one you ever see. This occurs the most in nature. This is saying the rate of change is relative to the size of the thing times some constant. So all kinds of things change that way. Populations change, money in a bank account. Unfortunately, viruses change this way. So the more of it is there, the more there is present, the faster it's going to change. This will give us exponential growth. So when they ask us for a particular solution, they're asking us to find this variable equals, so y equals. So how we're going to do that is we're going to separate variables. So we're going to multiply y over here. So we're going to get 1 over y dy. We're going to multiply dt over here. So we're going to get k dt. That allows us, now we have the integrals, or we have the sides in terms of one variable. So that allows us to integrate. The antiderivative over here is natural log of the absolute value of y. The antiderivative of k, the number k, is going to be kt with a plus c. We're only going to do the plus c on the right because if we did a plus constant over here and plus constant we subtract, we would just be back to a constant. Pretty soon you'll be able to just skip all of this stuff, but the way we get an absolute value of y out of here is we do absolute value of y is equal to e to all of this. So we say absolute value of y equals e to the kt plus c. Okay, so we now have e to the kt plus c. This e to the kt plus c, this plus c is going to become an e to the c. So you can think of like an exponential rule opposite. So if we have x squared times x cubed, it's equal to x to the fifth. Well, if we have x to the fifth, we are certainly welcome to break it up into parts. X squared plus x cubed, so we could write it as x to the 2 plus 3 and then split that up into its own x cubed. So that's what we're doing here. Now, this e to the c is just a number. It's a number to a number power. So we're going to turn it into an a. It's going to become a plus or minus a, and it's going to become a b. That's going to bother people, but it is what it is. This happens every time. We'll see it enough that you'll just eventually start skipping it. You are welcome to go from here straight to answer, even from here straight to answer if you choose to. We're going to use this value here to find b. So if I plug a 0 in for t, I get a 5 out for y, e to the 0 equals 1, so b is just equal to 5. So my particular solution is y equals 5e to the kt. And that's the equation here that gives me that derivative. You want to take the derivative of it, you would get k times 5e to the kt, and 5e to the kt is just y. So we get k times y. All right, so another one very similar. So I'm going to take the L over here. So I'm going to get 1 over L dL equals 2 dP. So same idea here. I get natural log of the absolute value of L, antiderivative of 2. So I'm integrating here. With respect to P is 2P plus C. If I want to get this L out of here, I get absolute value of L equals E to the 2P plus C. So that plus c is going to be e to the c is going to be a plus or minus a, then b. So L is going to be equal to be to the 2p. And if I plug a 0 in here and 100 out, that means b is going to equal 100. So you'll notice we get that same one quite a bit because it's a pretty famous type of problem. Down to number 3, we're going to get one that actually looks different. So when I multiply y across, I get y dy equals x dx. So I multiply the x over there. So I'm going to integrate. So I get the antiderivative of y is 1/2 y squared. The antiderivative of x is 1/2 x squared plus a c. Now, it's your choice. I know eventually this, if I'm going to solve for y, it's going to have a square root. So I'd probably find c right now. So if I were to plug a 1 in for x, I get 1/2. If I were to plug a 2 in for y, I would get 4 divided by 2 is 2. If I subtracted that 1/2, I would get c equals 3/2. So that means I have 1/2 y squared equals 1/2 x squared plus 3/2. Now you might be asking why on these ones did I wait till the very end to find b? And why did I go ahead and find c first? Just is where it's easier. On these types of problems, it's easier to wait till the end. On this problem, it's easier to do it now. Now I'm going to solve for y, so I'm going to multiply both sides by 2. So I get y squared equals x squared plus 3. Then I'm going to square root, so I get y equals plus or minus the square root of x squared plus 3. Now, this plus or minus is saying that things come out of here could be plus or minus, but in fact, since this point that we got had a positive value, we will just get y equals the square root of x squared plus 3. If this had been a negative y value, we would have just got the negative square root. So there is my particular solution. I'm going to stop there. I'm going to come back with 4 through 7 here in a sec.